Welcome to the channel. The purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our today's topic, that is radioactivity. Students, the spontaneous process means it is a natural process in which what happens? An unstable heavy nucleus breaks up into two or more lighter nuclei with the release of subatomic particles or gamma rays to get stability is called radioactivity. Students, number one, it is a natural process in which unstable some nuclei are unstable naturally and they want to get stability. For this purpose, they split up and they are broken into comparatively lighter nuclei with the release of some atomic particles or gamma rays. They are known as nuclear radiations. So with the release of nuclear radiations, a heavy nucleus breaks up into two or more comparatively lighter nuclei to get stability. This phenomena is called radioactivity. And these nuclear radiations are of three types. The emitted radiations during the process of radioactivity, they are of three types. What are they? Number one, alpha particles. Number two, beta particles. And number three, gamma rays. These are the three nuclear radiations. Let us discuss them one by one. First, taking alpha particles. Students, these are actually helium nucleus. You know, in helium nucleus, there are two protons and two neutrons. So, an alpha particle has double positive charge and its mass is equal to that of 4 nucleons. Therefore, we say that it is a helium nucleus. Charge on alpha particle is equal to that of 2 protons, and due to its heavy mass equal to that of 4 nucleons, we say that it is a heaviest particles in all the nuclear radiations. Next, due to its high charge, it is most ionizing. You know, ionization is a process in which electrons are removed from the atom. So it is most ionizing. Its ionizing property is highest. And due to its high charge, it cannot penetrate more in a material. So it is least penetrating. It can be stopped. Look at this diagram. Alpha particle can be stopped by using a sheet of paper. When a nucleus emits alpha particle, its charge number Z decreases by 2 and its mass number A decreases by 4. Means when there is an alpha decay and one element changes into another element, and the new element will have mass number 4 less than the original and charge number 2 less than the original. The schematic equation is, if an element X with mass number A, charge number Z undergoes alpha emission, a new element Y is formed with its mass less by 4 and with its charge number less by 2 with the release of alpha particle. Means from the parent nucleus 4 nucleons have gone and 2 protons have gone in the form of alpha particle. 2 protons and 4 nucleons means 2 protons plus 2 neutrons. So when alpha particle is emitted, mass number decreases by 4 and charge number decreases by 2 further with the release of energy. Q is the amount of energy released during this alpha decay. For example, if uranium 92-238 is an unstable nucleus, when it undergoes alpha emission, means when an alpha particle is emitted from uranium, it changes into thorium. New element is formed with Z number 90 and mass number 234 with the release of alpha particle or helium nucleus plus energy. So this is all about alpha particle. Next is beta particle. Students, beta particles are actually electrons with the negative charge equal to that of electron, and their mass is also equal to that of electron. So due to their less charge, they are less ionizing. They produce less ionization as compared to alpha particle. However, due to their less charge, they are more penetrating. They can pass through the sheet of paper. However, they are stopped by using aluminum foil. So they can pass through the paper. They are more penetrating than alpha particles. When a nucleus emits beta particle, its charge number increases by 1 or decreases by 1. There are two possibilities. However, at this school level, we will only discuss that its charge number increases by 1 and its mass number remains same. Look at this equation in which an element with mass number A, charge number Z undergoes a beta emission, means emits a beta particle. It changes into new element with the same mass number but different charge number with the release of beta particle. It is beta negative. There is a beta positive that we will discuss in college section with the release of energy. For example, when carbon 614, carbon with atomic number 6, mass number 14, undergoes a beta emission, emits beta particle. It is an unstable carbon. So to get stability, it emits beta particle and it is converted into nitrogen. It is changed into nitrogen, or we say that nitrogen 714 is formed with the release of beta particle plus energy. So this is all about beta particles. And third is gamma radiations. These are high energy electromagnetic waves. No charge, neutral, means least ionizing. They are having no charge, so they are least ionizing, most penetrating. They can pass not only from paper but also from aluminum foil where the beta particle were stopped. What we will do to stop them? We will use lead to stop gamma radiations, a thick plate of lead, because they are most penetrating. When a nucleus emits gamma radiations, its charge number and mass number remains same. It means that element does not change. What happens when a gamma ray is emitted? A particle or a nucleus gets stable from unstable state. If a nucleus with mass number A, charge number Z is in excited state, it releases extra energy and gets de-excited. However, it does not change into new element due to gamma emission. It is only the extra energy that it emits. For example, cobalt 2760 in excited state de-excites with the release of gamma radiation. Cobalt remains cobalt. However, it gets de-excites by emitting gamma radiations. Now students, these are the three types of nuclear radiations. What is the unit that is used for activity? The SI unit of radioactivity is becquerel. BQ is the symbol. It is named after the name of scientist Henry Becquerel. 1 becquerel means 1 disintegration per second. If one atom or one nucleus is changing in 1 second from parent to daughter, then we say that the radioactivity is 1 becquerel. The commonly used unit of the radioactivity is curie. It is again after the name of a scientist. And 1 curie equals to 3.7 10 raised to the power 10 disintegrations per second. Students, it is all about radioactivity. I hope it is clear. Students, thank you for sparing your time. If you liked the video, don't forget to subscribe the channel. Take care of you. Goodbye.